Hi, this is what I'll be coding today. What we have here are two arms that wrap and unwrap themselves around a sphere or ball, whatever you want to call it. And perhaps I'll be spicing this up a bit, but let's get started with the code, okay? So we're going to have the number of arms, 2. We're going to have the number of dots per arm, or stars, whatever you want to call it, doesn't really matter. They're going to look like dots in the beginning, and then we're going to give them the star shape, okay? So the total number of dots is going to be the number of arms times the number of dots. So here we're going to put everything inside a ball wrapper, and we're going to have a loop. So for I going from 0 all the way up to n, increment this I at every step. It would be great if I could type. Dot. Okay, now we'll be taking this loop and slightly altering it inside a style element so that we can set some custom properties. So here, this is going to be the number of arms, and we're going to have dot nth child n plus all the dots for the previous arms. So I times the number of dots per arm plus 1, because this index is 1 based, not 0 based. Okay, so having done this, we're going to set a custom property to the loop index, and then we're going to have something very similar right here. So we're going to take this out, and here we're going to have, of course, the number of dots, and here we're going to have every n dots. Okay, and here we'll be setting a second custom property. Also, we want to set the number of rotations around that sphere or ball, whatever you want to call it. So let's say it's going to be something like that. And here in a style attribute, we'll be setting the number of arms, the number of rotations, and all that stuff. So the number of arms. Okay, so having done this, let's copy paste it and delete that. Okay, so having done this, one more copy paste. Okay, so this is going to be the number of dots. So having done this, let's start by setting some styles on our dot elements. We'll be setting a radius here, so let's say something like 0.5 ems, and here we'll be having a padding equal to that radius. We'll be setting a dummy background. Okay, let's also set border radius 50% so that we can see a difference between them. Now, if you've seen my previous videos, you know I like to do this for layout because it's pretty much the simplest thing we can do. So display grid, and here we'll be setting place self center. So this places an item in the middle of its grid cell, in the middle of the grid cell it occupies. Okay, now something else we want to do is make them all overlap. So we want them to occupy the same grid cell. So that's going to mean grid area, the cell at the intersection between the first row and first column. Now let's set a few things on the body. So first up, make it full height so that the dots are in the middle vertically as well. Let's get rid of the scroll bar, margin 0. Let's also set a perspective, 25 ems. And something else, let's say that here we'll be setting an HSL value, and we'll be having a hue here. We're going to max out the saturation to 100%, 75. Okay, now here we'll be setting a background. We want that to be dark but not completely black, so let's say something like this, and now we can just minimize the body, and yeah, let's say that the hue is going to be calc, let's say it's going to be J over the number of dots times 360. Okay, so having done this, we're not going to see anything for now, But let's say we're going to set transform, and we're going to distribute these things first in the plane and then in 3D. So let's say we're going to have rotate around the third axis, and we're going to have a calc. Let's say this is going to be j over the number of dots times half a turn, or 180 degrees, whichever you prefer, it doesn't really matter. And let's also set a translation. We're going to use a dummy value, something like 8 ems for now. So it's going to look something like this. But we want this to start not from 3 o'clock, but from 12 o'clock. So for that, we're going to subtract 90 degrees. Okay, so having done this, let's set this to, okay, and then we're going to have something similar for the y-axis. So y, this is going to be I over the number of arms times 1 turn, and we're not going to have that subtraction anymore, okay, because we don't care for that in so here we'll be replacing with y. Okay, now one problem there, you see we have that little gap there, and that's because this j index, its smallest value is 0, and its biggest one is the number of dots minus 1. So for the first value, this ratio is going to be 0, but for the last value of j, the number of dots minus 1, the ratio is not going to be 1, it's going to be slightly smaller. So to make it be 1, let's subtract 1 from there. So this should, oh, not there, here, that's the hue. I was looking at the wrong thing, sorry. Okay, so this fixes it. Now here we're going to add another ratio, and we're going to call this k, and it's going to fall back on 0. So here for this k we're going to have calc, and this is going to be the number of rotations around the sphere times j over, and it's basically going to be the same thing as we have right here. So you can just copy paste that, so j over. Okay, so this doesn't really look like anything, it's very messy, but if we increase the number of dots, let's say something like this, it's starting to look like something, but you see those dots get rotated, and we see them from the side, and it's really hard to understand anything. So we're going to reverse these rotations. So the way we do that is we're going to use a calc. Oops. I shouldn't be trusted with a keyboard. Okay, so something like this. Now here, reverse the y rotation as well. So that should do it. And it's starting to look like something. And we can add another one, right? And this one is going to be around the x-axis, and initially 0 degrees. So let's replace that. Actually, I should have waited until reversing it, right? So reverse that. Okay, and now I'm going to want to animate that. So to do that, we need to register it. So property, and syntax, this is of course going to be an angle. Initial value is going to take 0 degrees, and inherits is not necessary, and we set it to false. This should help with performance as well. So now that we've done this, we're going to have a set of keyframes here. So keyframes 2, 1 turn. So now we'll be setting here an animation duration, something like 6 seconds. And we're going to have animation, linear, infinite, okay? And you can see that the 3D order looks very wrong, and that's because these dots are not part of the same 3D context. So let's fix that. So we're going to set on the ball, transform style, preserve 3D. So that should fix the 3D order. Okay. Now they look in 3D order. That's good. So having done this, let's have a second animation that makes those arms unwrap. So we're going to register K as well. So we're going to register K. This is going to be a number. Okay, and its initial value is going to be 0. And for the animation, we're going to take this value from here. We're going to have keyframes K, 2, and it's going to be something very similar. So we want K to go from this value to -1 times this value, and multiplying with -1 means simply reversing the order in that subtraction. So now we need to add the animation. So let's say it's going to have twice the duration, ease in out, infinite, alternate. So let's see that. Okay, you can see it unwrapping, okay, and then it wraps again in the opposite direction. Okay, cool. But one problem that we have is that those balls end up being too close and they overlap when we unwrap the thing. So let's fix that. Let's say we're going to have something like a unit, and let's say it's going to be 3. We're going to have a number of repetitions of this unit, let's say 24. We're going to take the number of dots from there and compute it here. So now we're going to have the unit right here. Okay, so having done this, we're going to have groups of 3 dots, and the dots on the side in that group, because you have 1, 2, 3, so, or 0, 1, 2, because those are the indices we're going to have, 0, 1, 2. So we want the 2 dots on the side to scale down to 0 when we unwrap the arms, and then when we wrap the arms again, they're going to scale back to 1. So that's what we want to do. So we're going to compute basically a mid index in such a group. So this is going to be calc 0.5 times the unit minus 1. Because as I said, the indices, so if the unit is 3, the indices in a group are going to go 0, 1, 2, right? And here, if u is 3, then we're going to have 0.5 times 3 minus 1, so 0.5 times 2, so that's going to be 1. So that's basically the middle index, okay? Now we're going to compute the floor of the division between this j index and the unit. So this is basically going to be an integer value, calc, and this is going to be j over the unit minus 0.5, and we're going to force this to be converted to an integer by registering it as such. But we don't want this to go below 0, which can happen if we subtract that 0.5. So we're going to set maximum between 0 and that. So, okay, so now that we've done this, we're going to take this, and this is going to be that integer value, and of course its type should be as such. Now let's collapse these as well. Okay, now we're going to get the modulo. So the modulo is going to be j minus that integer value times the unit. And now we're going to want to have the absolute value of the difference between this mid-index and this modulo. So this modulo is basically going to be it's going to be those indices within the groups. So 0, this modulo can mean either 0, 1, or 2, okay? So the absolute value is going to be the maximum between the middle m minus the modulo, and the modulo so if the modulo value is bigger than m, then this is going to be negative and this is going to be positive, and the maximum is going to be this one, taking the positive one. So, and if it's smaller, then we're going to take this one, because this one is going to be the positive one. Okay, now we're going to animate a scaling factor f. So scale, and this is going to fall back on 1, and of course we're going to need to register that as well. So we're going to register this, and it's going to be, and its initial value should be 1, okay? Because otherwise it just scales everything down to 0 by default. Okay, so having done this, we're going to animate that factor. So it's going to be something pretty similar. So, and again, we're going to have a calc here, but we're going to have something different in there. So we're going to take the difference between this mid value and this absolute difference, and we're going to multiply it by 2, and we're going to divide it by the unit. So this is going to give us numbers between 0 and 1, ends included. Okay, so twice and we're going to divide this by the unit. Okay, so now we're going to take this and of course let's make it just ease in and let's see it. Okay, something went wrong there. The effect is interesting, but this is not what I wanted. So that's j there, that's good. So let's see those integer values, because I have no idea what I messed up there. So minus the absolute, okay, that should be good. Oh, yeah, my mistake. Now it works, you see, it works. Okay, that's great. Now we can compute that translation value. So we're going to compute a tangent here. So the tangent is going to be, so we're going to have that number of repetitions times pi over the number of dots, and we're going to divide by 2 or multiply by 0.5, and we don't want that many decimals, okay? So we're going to do something like this. That should be enough. So here we're going to get the tangent. Okay, so having done this, we're going to set this right here. So we're going to have calc that radius over the tangent. Okay, something went wrong. So the number of dots. Oh, not the number of repetitions, the unit, sorry. Yeah, that was silly. Okay, so yeah. And if you want them a bit more spaced out, we can add a multiplier there. And it's going to look something like this. Now let's turn them into stars. Okay, so we're going to have a mixin star, and it's going to take a number of points for our star, let's say 8, and we're going to have a pointiness factor, let's say 0.5. Now this is something I explained in a previous video, and I'm going to link to that stuff below. So here I'm going to have, first off, the number of vertices for the polygon, and this is going to be twice the number of star points. Then I'm going to have a base angle, and this is going to be 360 degrees over the number of vertices, and we're going to have a list of points. Okay, so having done this, we're going to have a loop. So for I from 0 all the way up to the number of vertices, we're going to compute a current angle, and of course let's set an offset angle here, and this is going to be minus 90 degrees again, so we don't start from 3 o'clock but instead from 12 o'clock, and this is going to be I times the base angle plus the offset angle. Okay, so having done this, we're also going to compute a current radius, and actually we can compute the inner radius. So this is going to be that pointiness factor times cosine of half the base angle. Okay, so here I'm going to have the current radius, and we're going to have a condition. So this is going to depend on the parity of I. So if this is greater than 0, we're going to use that inner radius, otherwise we're going to use 1. So this is going to be basically like a relative current radius. And to this list of points, we're going to add, first up, the x-coordinate. And this is basically the offset, which is going to be 50%, times 50% times that relative current radius, times cosine of the current angle. And of course, we can bring out in front that 50%, right? And we put everything within parentheses, and it's going to look something like this. Okay, so then we're going to have something very similar for the y-coordinate, except we're going to have sinus there. Now here we're going to have a polygon, and this is going to be the polygon function, and it's going to use that list of points. Okay, so having done this, we're going to set clip off. So something very similar. So now we're going to call this mixin. Of course, we're going to need compass, otherwise the trigonometric functions are not going to work. So import compass. So something like this. Let's collapse the mixin, and let's include and I messed up something. We're going to see. Okay. So yeah, this is actually looking like something right now. But since we're here at the hue, let's do something else So we're going to compute something similar to this integer, but for I, for its parity. So we want modulo, so I modulo 2. So we're going to have to compute something very similar to what we have right here. So basically, of course, this is going to be I, right, everywhere there. And this is not going to be U, this is going to be 2. Of course, that there is going to be I. And we're going to want to register that integer, that floor value. Okay, so now that we've computed that modulo there, we can have a better kind of computation here. So let's say this is going to be times 180 and 1 plus, and here we're going to multiply this whole thing with 1 minus twice. So it's basically going to be minus 1 if this modulo is 0 and 1 if that modulo is 1. Right, so it's going to take into account the parity. Now, let me show you why I did that. So if we have, let's say, 4 arms, it's still going to look nice and clean. So we're going to have the same colors at each end, even though the transitions are different. So one is going from 0 to 180, the other one is going from 180 to 360, which basically gives us the same hue as 0. But yeah, okay, 2 arms, because with 0 we don't see anything. But here I want to show you, when it unwraps completely, we just have the entire hue circle on it. So that is it. And I think I'll stop talking, stop tweaking it. This is pretty much what I wanted to show you for today. I hope you've enjoyed this video, and if you have, if you like the work that I've been putting out for almost 9 years now, please consider supporting it so I can continue doing stuff like this in the future. You can do so by being a cool cat and becoming a patron on Patreon. The link is going to be in the description. Or you can get me something off my Amazon wishlist. Again, the links are going to be in the description, as well as links to resources for understanding stuff in this video. Or you can at least share this to show the world what can be done with CSS these days. Because honestly, I think it's pretty damn cool. In any event, thanks for watching, and until next time. Bye!